Right now, the video you're watching is a stream of 1 second and 0 second that just zoomed across continents, under oceans, and through a complex web of cables to reach you. But how does it happen so fast? Why don't we use satellites? And what's the secret behind the internet's insane efficiency? Stick with me, because we're about to take an epic journey from a Google data center to your device. The internet is a massive, global network of computers, servers, and devices all talking to each other. Think of it like a digital highway system, connecting billions of devices through a complex web of optical fiber cables, routers, and servers. Whether you're streaming this video, scrolling social media, or gaming online, it all relies on this incredible infrastructure. But how does data like this video find its way from a data center thousands of miles away to your phone or laptop? Let's break it down. You might think satellites are the obvious way to send data. Picture this: a signal shoots from a data center to a satellite 22,000 miles above Earth's equator, then back down to your phone. Sounds cool, right? But here's the catch. That's a 4,400-mile round trip. That distance causes a delay called latency, which can make your video buffer or your Zoom call lag. For most internet apps like gaming or streaming, latency is a deal breaker. So, satellites are great for GPS or TV, but for the internet, not so much. Instead, we rely on a hidden hero: optical fiber cables. These are the real MVPs of the internet. Optical fiber cables. These super thin glass strands carry data as pulses of light, stretching across continents and under oceans to connect data centers to your home. Imagine a ship dropping a plow into the sea to bury these cables in trenches on the ocean floor. That's how we build the internet's backbone. Companies like Google and Subcom maintain this global network, ensuring data can travel thousands of miles in a blink. From the data center, these cables link to routers, cell towers, or Wi-Fi, bringing the internet right to your device. Let's zoom into the data center where this video lives. Inside, it's stored on a solid-state drive in a server, a powerful computer designed to deliver content like videos, websites, or apps when you request them. When you click play, the server gets to work, chopping the video into digital bits and sending them through those fiber optic cables. But how does it know where to send them? That's where a crucial concept comes in: the IP address. Every device on the internet, your phone, laptop, or the server holding this video, has a unique IP address, like a digital home address. For example, your internet service provider assigns your phone an IP address, like 192.168.1.1, so data knows exactly where to go. Think of it like mailing a letter. Without an address, it's lost. Servers and data centers have IP addresses too, but remembering strings of numbers is tough. That's why we use domain names like youtube.com, which are easier to recall. These domain names are linked to IP addresses through a system called DNS. DNS, or Domain Name System, is like the internet's phone book. When you type youtube.com into your browser, it sends a request to a DNS server run by your ISP or organizations like Google to find the matching IP address. The DNS server says, "Oh, youtube.com, that's 172.217.01. Your browser then uses that IP address to connect to the right server in the data center. Without DNS, you'd have to memorize numbers for every website. Yikes. Now, let's talk about how the data actually moves. When you hit play, the server breaks this video into tiny chunks called packets, each carrying a piece of the video, plus the server's and your device's IP addresses, and a sequence number to keep things in order. These packets race through the fiber optic cables, often taking different routes to avoid traffic jams. Some might zip under the Atlantic, others through a land-based cable. When they reach your device, they're reassembled like a digital puzzle. If a packet gets lost, your device sends a resend request. This process is managed by protocols rules that ensure packets are sent, received, and reassembled correctly. Think of protocols like traffic laws for the internet, keeping everything orderly. Different apps use different protocols, like HTTP for websites or RIMP for streaming, making the internet super efficient compared to old-school phone networks. The internet is a global beast, so who keeps it in check? That's where ICANN, the Internet Corporation for Assigned Names and Numbers, comes in. Based in the USA, ICANN oversees IP address assignments, domain name registrations, and more, ensuring the internet runs smoothly. Without this coordination, it'd be digital chaos. What makes the internet so fast? Unlike old phone systems, where calls took a fixed path, the internet's packets take the best available route, adapting in real time. This flexibility, plus the speed of light through fiber optics, means data can cross the globe in milliseconds. Compare that to mailing a letter, it's like teleportation. This efficiency is why you can stream HD videos, game online, or video call without missing a beat. Wow! Isn't the internet incredible? From data centers to your phone, this global network is a modern marvel. Want to dive deeper into tech topics like this? Smash that like button, share this video with your tech-savvy friends, and subscribe to CyberSage for more mind-blowing ICT lessons. Check out the link in the description for a free guide on internet basics. Drop a comment. What's the most surprising thing you learned today? Let's geek out together. See you in the next video.